Hi students, today we have MCQs part 1 for pair of linear equations in two variables. So let us begin with today's class. Here is the first question. We have two linear equations given, that is 4x plus 6y is equal to 9 and 2x plus 3y is equal to 6. So here we have to say how many number of solutions these two equations can have. So without solving the problem, how we can find the answer here? Yes, you're correct. So when we have two equations given, how we can find the solution here? By comparing the ratios of the coefficients of the variables x and y as well as the ratio of the constant. So if you observe, when we compare the given equations to the standard form, we have a1, b1, c1 and we have a2, b2, c2. So if we compare the ratios, we can see how many number of solutions the two equations will have. Therefore, let us compare the ratios. A1 by A2, that is equal to 4 by 2. Then B1 by B2, which is equal to 6 by 3, as well as C1 by C2, that is equal to 9 by 6. So if we simplify this one, I'll get A1 by A2 is equal to 2, B1 by B2 also equal to 2 and C1 by C2, that is equal to 3 by 2. So when we write it in the format, I'll get 2 is equal to 2, which is not equal to 3 by 2. So when we compare this with the given conditions here, what we'll get? We'll get it matched with no solution. So when we have the ratios a1 by a2, that is equal to b1 by b2, but it is not equal to the ratio of the constant, will have no solution for the given equations. Therefore, the correct answer here is option A, no solutions. Let us move on to the next problem. Here is the second question. We have, which of the following pairs of the equation represent inconsistent system? So we already learned about consistent and inconsistent system. So what is the condition for inconsistent system? The condition for the inconsistent system is the two equation should not have any solution. Therefore, we should compare the ratios of the coefficients of the variables, and if the ratio a1 by a2 is equal to b1 by b2, but if it is not equal to c1 by c2, then there is no solution. Therefore, the system is inconsistent. How we can check this over here? So we can just go with trial and error method here. Just observe here, we have 3 and 2, then we have -2 and 3, 8 and 1 in the first option. By looking at the option itself, we can say it will have a unique solution because a1 by a2, that is not equal to b1 by b2 over here. So if you go to the second option, we have 3 and 3, then we have -1 and -1, then we have -8 and 24. So if you observe this one, we can get that 3 by 3, that is equal to -1 by -1, which is equal to -8 by 24. So here a1 by a2, those are equal to each other, but it is not equal to c1 by c2. So we can select this option. But we also have to look at the remaining two options. So if you observe, the third option we have L by 1 and we have -1 by plus m. Therefore, this will also have a unique solution. Correct? Now, let us look at the last option. So here we have 5 by 10. Then we have -1 by minus 2, also we have 10 by 20. So this gives us 5 ones are 5 twos are, so 1 by 2. Then in the second ratio, minus and minus gets cancelled, that is also equal to half, and we have 10 ones are 10 twos are. So here all the ratios are equal, therefore the last option will have infinitely many solutions. Therefore, which is the correct answer here? You're correct. The correct answer here is option B, 3x minus y is equal to minus 8, and the second equation is 3x minus y, that is equal to 24. So we'll move on to the next problem. The question here is the graphical representation of the pair of equations x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0 is. So here, without solving this graphically, we can find how the lines will be. How we can find it? We can find it just by comparing the ratios as we did it in the previous two problems. So observe here what and all we have. So if you observe, we have A1 is equal to 1, A2 is equal to 2 and B1 is equal to 2, B2 is equal to 4, C1 is equal to minus 4 and C2 is equal to minus 12. So let us write the ratios to just compare them. We have 1 by 2, then we have 2 by 4 and the third ratio here is minus 4 by minus 12. Therefore, 2 ones are 2 twos are, so minus and minus gets cancelled here. 4 ones are 4 threes are. So the ratio here is 1 by 2, that is equal to 1 by 2, but it is not equal to the ratio of the constants. Therefore, here we are getting A1 by A2, that is equal to B1 by B2, but it is not equal to C1 by C2. So when we solve these two equations graphically, we'll get the lines parallel to each other. Therefore, the option B is the correct answer. We'll move on to the next question. So here we have given with AM is not equal to BL, then the pair of equations AX plus BY is equal to C, LX plus MY is equal to N will have how many number of solutions? So don't get confused just because of we have different letters over here. You can just compare it with the standard form A1x plus B1y is equal to C1 as well as A2x plus B2y, that is equal to C2, and using this we can write how many number of solutions the given equations will have. So here I've just taken both the equations whatever we have given to us, and based on that here there is unique solution, no solution and infinitely many solution will have these conditions, right? So here one thing we have to observe that we have given with AM is not equal to BL. So here if you observe, this is not the equation, this is known as inequation. So how we can solve the inequations here? To solve this inequations, what I am going to do here is AM is not equal to BL. Therefore, we can't move from left to right or right to left. Therefore, here to eliminate M from here, I am just dividing by M on both the sides. It becomes A, which is not equal to BL by M. Correct? Now, here I would like to eliminate L from this L from the right hand side. So what I am going to do, I will divide both by L. So here when I rewrite this one, it becomes A by L, which is not equal to B by M. So if you observe, this condition gets satisfied here with a unique solution, right? Therefore, we can just select the answer directly. Therefore, the option A, which is the correct answer. We'll move on to the last question of this class. Here is the question. For what value of k, the pair of equations 4x minus 3y is equal to 9, 2x plus ky is equal to 11 has no solutions. So here, as we have seen in the earlier problems, the condition is the same. To get no solution, we should have the first two ratios, that is a1 by a2 should be equal to b1 by b2, but this ratios should not be equal to the constant ratio. Therefore, let us see how we can solve this problem. Here we have given with a1 as 4 and a2 as 2. Next, b1 as minus 3 as well as b2 as k. Then we have c1 as 9 as well as c2 as 11, right? So here the third one will not matter much. We just have to look at the first two, that is a1 by a2 and b1 by b2. So here we have 2 ones are 2 twos are. Therefore, the second ratio should be equal to the first ratio. Therefore, we can have the equations parallel or the lines parallel, which has no solutions. Now we have minus 3 here, right? So for which value we can get it as equal to 2 here? For what value of k we can write it equal to 2? So if you observe, we have the negative sign here, right? So here the easy method to solve this problem is, first we have to look at the negative sign. If we see, the ratio of a1 by a2 gives us 2, that is just the positive value, right? So here in the second one, that is b1 by b2, we have the negative sign here. We have to eliminate this sign. Therefore, the value of k should contain the negative sign. Therefore, if we look at the options here, we can directly eliminate the option A and B, because which doesn't have the negative sign. So here we have the option C and D. So we can just go with the trial and error method. We have minus 3 by k, that is equal to minus 3 divided by 1. Just I am taking the fraction here so that I can simplify. Okay, divided by, in place of k, if I substitute minus 3 by 2, what happens? Which is equal to minus 3 by 1 into minus 2 by 3. Hope you all know how to simplify the fraction like this, right? So we have to take the denominator to the numerator and multiply with the reciprocal of the denominator. So it becomes 3 and 3 gets cancelled here, minus into minus plus 2. So we are getting 2 for the value of k is equal to minus 3 by 2. Therefore, the correct answer is option C. But before that, let us just clarify if the fourth option works. Okay, so minus 3 by 1 whole divided by minus 2 by 3. So when we simplify this one, minus 3 by 1 into 3 by minus 2. This gives me the answer 9. Therefore, option D also can be eliminated. The correct answer here is option C, minus 3 by 2. So, students, let us go to the concepts whatever we have come across in today's class. So here I have the important points which you should remember, right? Here in this chapter we have only these concepts which are important and you should remember all these. Okay. When we have two equations given, that is a1x plus b1y plus c1 that is equal to 0, as well as a2x plus b2y plus c2 is equal to 0. By comparing the ratios of the given equations, we can just tell how the graphical representation of the equations will be, how many number of solutions this equations will have, as well as how the system is. Correct? So here, when a1 by a2 that is not equal to b1 by b2, we can say that we'll get the intersecting lines when we solve them graphically, as well as these equations will have a unique solution, or we can also say that only one solution, and the system is consistent over here, right? So next we have a1 by a2 which is equal to b1 by b2, but it is not equal to the ratio of the constant, that is c1 by c2. Then we'll get parallel lines when we solve the equations graphically, as well as these two equations will not have any solution and the system is inconsistent here, right? The last one, when we have all the ratios equal, that is a1 by a2 equal to b1 by b2 and that is equal to c1 by c2, the lines will coincide each other graphically. That means the first line will come upon the second line, or we can also say that the second line will come on the first one. So since both of the lines are intersecting each other at many points, we can say that these two equations will have infinitely many solutions and the system is consistent. Hope this is clear for all of you, right? So here, remember that the system is consistent only when it has a solution. Yes. So system is consistent only when it has a solution, and system is inconsistent when there is no solution. Right? So these wordings you have to remember, because these are the important things which you get in exams. So I'll come up with MCQs part 2 for the same chapter. So for now, I'm going to end the class. Keep watching, continue learning. We'll meet in the next class also. Don't give up. See you soon. Thank you.